Today, we're here in Trust Coraces, Minas Gerais, to show you how gas cylinders are made. Shall we take a look? I don't know about you, LD, but I've always been really curious about gas cylinders. In fact, on Manual do Mundo, we've even cut one in half to see what's inside. Because we have this thing in the kitchen, it's full of flammable gas inside, and it has to be extremely safe. So today we came to a factory to understand how it's made. The gas cylinder is basically made up of 5 large pieces and 3 smaller ones. I'll put it together so you can see the base ring, which is its base, the lower dome, the upper handle, which is where we hold it, and the flange. On the flange are the valve, where gas exits, the safety plug, a fire protection device we've shown on Manual do Mundo, and the tear plate, which shows the cylinder's empty weight. The most common cylinder is the P13 because it can hold 13 kgs of gas inside it. But here, they also produce other pressure vessels, which is the technical name given to the cylinder. Each one needs a specific design, depending even on the substance it will store. In the cylinder we have at home, it's usually LPG, which is liquefied petroleum gas. Yes, that's exactly what you heard, liquefied, because inside the cylinder, it stays liquid due to the pressure, and because of that, we can store much more material. Besides the physical challenges of storing gases and liquids, the cylinders need to go through a series of safety standards. And all of this is guaranteed at this stage of production in the design. Each of these parts here will become reality on the production line. The main raw material is steel, and it arrives in these coils, which can weigh up to 12 tons. But here something similar happens to when you buy a poster board and roll it up. When you unroll this coil, the steel will be curved. To fix this, the material goes through the leveling line. There are several rollers that straighten the steel. Next, this sheet will be cut by super powerful presses, which have a kind of blade at the tip, like those cookie cutters. Here, circles and rectangles are formed that will become the body of the gas cylinder. The distributor brands and registration numbers are also stamped using presses. And at the end of the process, they check the measurements to make sure everything is correct. These circles will now go through a hydraulic forming press. They get a little bit of oil, and then the machine presses until it forms half of the cylinder body, like half of an Easter egg. The rings need to go through a rolling machine, which is a type of press that can bend the piece, forming a ring. After that, it gets a weld at the joint, and then a bend is made to create that curve that makes the piece more ergonomic for us to hold. For the flange, the process is different. That's where the valves go, so it has a thread that is machined inside the piece. To join the two parts, they need to make a kind of fitting, so the top part goes through a cutting process, and the bottom part goes through a beating machine, which forms a small ridge, a kind of little ridge. The parts will all be joined using a type of mishmag welding, where wire is melted using an electric arc, and at the same time gas, which can be a mixture of carbon dioxide and argon, to protect the weld bead that is formed, so there are no defects in the weld. First, they weld the handles and the flange, and then the two halves are fitted together at the end, in what they call a circumferential weld. The cylinder is almost ready. Here all the parts will go through an inspection to make sure everything is correct. The cylinder already seems nearly finished. Just spray it and it's ready. But no, it still needs to go through heat treatment, which is called annealing or stress relief. In this process, each cylinder is heated up to about 650 degrees Celsius and then cooled down. This has to be done because welding creates some stress points in the steel structure, and these points can become weak. The heat treatment will make the steel reorganize itself and eliminate these stress points. To know if the annealing actually worked, several tests are carried out in which the cylinder is pushed to its limit. Mechanical test, where the steel is stretched until it breaks, water jacket test, to check whether the cylinder flexes properly, and also burst test, which is literally filling it until the cylinder explodes. Let's see this happening now. What kind of noise do you think this is going to make? Let's see how it turned out.
No.
Wow. It turned into a little ball and cracked on top here. We can see it from the water coming out. When it burst, I wasn't looking at the gauge anymore, but it was over 80 times atmospheric pressure, which means it's more than 5 times what it needs to withstand at home. Here, the pressure in bar shows how many times atmospheric pressure is in the cylinder. It's almost time for it to burst. I felt the little rain right here on top of me. The cool thing is that there's a pattern. It's always more or less at the same spot. If a gas cylinder exploding isn't worth a like, I don't know what is. The cylinders can't be painted right after coming out of the oven because they're covered in residue. If you look closely, you can see it. It's kind of dirty. So they're going to go through a machine that blasts them with steel shot. It's like steel powder. Looks like sand that will clean the cylinder. Of course, we can't see this up close because the process is very intense, but the steel shot is right here, look. Look how nice. It came out clean on the other side, and the surface is already a little rough to get ready for painting. The painting will happen in layers. First comes the anti-corrosion undercoat, which is applied by immersion, meaning the cylinders are dipped into the tank. Then there are 2 more layers, one of primer and another of enamel paint. They are usually the same color blue, yellow, silver, or green. In the end, these layers are cured. They are dried in an oven at 150 degrees. Now, it's time to put in the safety plug, which is a screw that has a bismuth alloy inside. Bismuth is a metal that melts very easily. So if there's a fire, this will melt and let the gas escape, and that's what ensures the gas cylinder will never explode in a fire. Right after that, they will do a pressure test on each of the cylinders. For this, high-pressure water is injected. By regulation, the cylinders need to withstand 17 times atmospheric pressure, but here they use 34 times, and there can't be any leaks. This test needs to be done with water, because if it were done with air, there would be a risk of the cylinder exploding if there was a leak. With water, that's not the case. If there's any small defect, only a little water will leak out. To install the valve, they first apply sealant, the part is fitted in, and then it's tightened with a torque wrench. It's a tool that ensures the force is always applied at the right measure. To make sure the valve doesn't have any leaks, they're going to pressurize the cylinder once again with compressed air and submerge it in a tank they call the big pool here. That way, you can see if any air bubbles come out. Look, I hadn't noticed this before. But they told me here the gas cylinder filled with air doesn't sink. How does it go underwater then? There's a magnet here under the conveyor belt. So if I try to lift the cylinder here, I can't, because it's stuck to the magnet. After this test, you must remove the compressed air inside, or the gas won't enter. Next, the cylinders go through a weighing process. All of them have to be between 13.5 kg and 14.5 kg. They check on the scale and then put a tear tag to indicate the weight of the cylinder. This marks the end of the production process. The most common cylinders will have the weight we mentioned, between 13.5 kg and 14.5 kg. But here they also developed another cylinder, which also has the capacity for 13 kgs of gas inside, but it's much lighter when empty. It weighs between 8.5 kg and 9.5 kg. This makes transportation much simpler, cheaper, and at home the cylinder is also much easier to carry. It's kind of magic. It feels like I got 4 kg stronger here. From here, the cylinders will be loaded onto open-frame trucks and sent to gas distributors. They are the ones who will put the LPG inside and send it to the homes of millions of Brazilians. When the gas runs out, they go back to the distributors to be refilled in a cycle that, if the cylinder is well taken care of, can last more than 40 years. So, the next time you see the gas truck passing by on the street, you'll remember all the hard work that went into making a product that's safe for you to use in your kitchen. Look, look. If you enjoyed seeing how the gas cylinder is made, you'll also like seeing how the aluminum can is made. We had to travel to 2 different states to understand the process.